Look at a CNC machine cutting apart, a gantry robot sliding across a cell, a pick-and-place head darting over a circuit board. They all depend on the same thing: moving a load along a straight line to a precise spot and knowing it got there. That is the topic today, and it is the quiet backbone of almost every precision machine on the factory floor. In this video, I will explain what it actually is, how you turn a spinning motor into straight-line travel, the closed loop that makes it accurate, and how a PLC or motion controller commands the whole thing. Let's start with the idea itself. Quick note before we dig in. This is from PLC Simulator, where you can practice motion and PLC programming free, right in your browser. No install, no hardware. The link is in the description. Click the link in the description to try it free. Now, back to the motion. So what is linear motion control? Strip away the jargon. It is controlled, repeatable straight-line positioning. You take a load, a cutting tool, a gripper, a print head, and you move it to an exact target along one axis, at a speed you choose, and you confirm it actually arrived. That last part matters. Control is not just movement. It is movement you can trust to the same spot thousands of times. A CNC table, a 3D printer axis, a gantry, a pick-and-place head, they're all linear motion control done well. Get this right, and the machine is accurate. Get it wrong, and the part is scrap. Here is the first real problem. Most motors spin, but you need straight-line motion. So the first job is conversion, turning rotation into linear travel. There are a few classic ways. A ball screw is the workhorse of CNC. A spinning screw drives a nut along its length, smoothly and with very high precision. A timing belt trades some accuracy for speed and long travel. Think of a 3D printer head. A rack and pinion handles very long axes, like a big gantry. And then there is the option that skips conversion entirely. A linear motor. It produces straight-line force directly, with no screw and no belt. That gives you the highest speed and the highest accuracy for a higher price. Rotary plus conversion, or a direct linear motor. Same goal, different trade-offs. Now the part that makes it precise. The closed motion loop. It is a simple cycle that never stops. The controller commands a target position. The drive powers the motor to move toward it. An encoder measures where the axis really is. And the controller compares command to actual, then corrects the difference, continuously, many times a second. That is the same closed-loop idea behind a servo motor. I have a full video on servos linked below. A stepper motor, also linked, usually runs open loop. It just counts steps and trusts they happened. Closed-loop motion is what lets a machine hold a position under load and catch its own error before it becomes a bad part. One more piece, the motion profile. You never just slam the axis to a position. That would jolt the machine and overshoot the target. Instead, the controller plans a profile. It accelerates smoothly. It cruises at a set velocity. Then it decelerates into the target. The fancy versions also limit jerk, the rate of change of acceleration, so the motion is gentle on the mechanics. The classic shape is a trapezoid. Speed ramps up, holds flat, ramps down. A PLC or a dedicated motion controller streams that profile to the drive as the axis moves. Position, velocity, acceleration, all commanded, all coordinated. That is how a pick-and-place head moves fast and still lands soft. So here's what to walk away with. Linear motion control is precise, repeatable straight-line positioning. You get the motion by converting a rotary motor with a ball screw, a belt, or a rack. Or by using a direct linear motor. A closed loop with encoder feedback makes it accurate, and a motion profile makes it smooth. Get those three ideas, and every CNC, gantry, and pick-and-place machine on the floor stops being a mystery. Now, go make it concrete. If you want to practice motion and PLC programming hands-on, click the link in the description to start free at plcsimulationsoftware.com. No hardware, no install. Subscribe, new video every Tuesday. See you in the next one.